Hi, my name is Mr. Kersey. I'm here and we're going to be looking at the effect that temperature has on the volume of a gas. So for this experiment, I have all the supplies you might need out here on the table. We'd start off, you're going to need some cold water, ice water ideally, some warm water. Again, you want it to be hot, but you don't want it to be hot enough where it's going to burn you. So definitely make sure it is not too close to boiling. In addition to that, you'll have two containers that you're going to be able to place the hot and cold water in. You're going to have some measurement device. In this case, I have a graduated cylinder, but you might have something else to measure with at home. If you do, you just want to make sure you convert your volume measurements into milliliters. You're going to have some bottle, which in this case I just have a generic water bottle, and then I have a timer and a thermometer, and then some tap water. So to start out, first thing we want to find out is we want to know exactly what the volume of our bottle is. So the easiest way to do this is we're just going to fill it up all the way to the top with water, and then we will figure out the volume of that water. So when you do this, you want to make sure it gets all the way to the very top. And it's okay if you spill a little bit because it is just water. All right, so this is full all the way to the top. I'm going to go ahead and pour it in my measurement device and figure out how much we have. Okay, so as you're measuring, again, always best to keep yourself eye level with what you're measuring. So if I look here, my water volume is going to be 530 milliliters. So this is a value you're going to need to make sure you record down. So here I've got my bottle volume is 530 milliliters. So you need to make sure you keep track of that, as it's going to be important later. So the next step that we have is you're going to get the temperature of our warm water. So here I've got my warm water, and you can see here that it's reading right around, I'd say 47. It's kind of bouncing around a little bit as I stir, which is fine, but it is approximately 47.5. So same thing, I'm going to go ahead and record that as my hot temperature. And again, I'm measuring in Celsius, so do keep track of what units you're measuring in. So next step is we're going to take our bottle and we're going to submerge it. Slightly too much water, so let me just empty that out just a little bit. And we're going to submerge it for 3 minutes. So I went ahead and started my timer. So we're just going to hold this underwater as best we can and then wait. So what this is doing while we were doing this is the gas inside the water bottle is still there moving around. And it's the warm water around it is going to actually increase the temperature of the gas that is inside the bottle, allowing it to kind of equilibrate and get the same temperature that we have as the water. So then that way we know the temperature of our gas. So basically, we still have 2 minutes. We want to make sure we give it plenty of time to equilibrate, and that way we know what temperature it is. One thing to keep in mind, make sure you have the cap of the bottle ready, because you're going to need that once the time runs out. Okay, as we're getting close, I'm getting my lid ready. I'm going to go ahead and make sure I put my cap on and seal the bottle all the way. And then I'm going to remove my bottle from the hot water. I'm going to turn it upside down, and we are going to place it into the cold water. Once it is in here, we're going to make sure we're going to remove the lid while it's underwater. It's very important it is underwater while you're doing this, because the pressure is changing so that it will actually end up sucking water up into the bottle. So now we are, again, going to, just like we did before, we're going to wait 3 minutes. So I will start that. While I'm doing that, I'm going to actually take the temperature of my cold water as well, which our cold water is approximately, I'd say about 2.8 degrees Celsius. So same thing, I will need to remember that and make sure I write it up on the board. And keep track of it. Okay, so time has been up. It's been 3 minutes. Now, if you look at it, you can see in the bottle there is a certain portion of water that is actually inside the bottle. Now, it is important that when you are getting ready to put the lid back on, you want to kind of level out the water that's in the bottle with the water that is in the container. That way there's no pressure difference and you get the right amount in there. So when it is at that level, you want to make sure you carefully put the cap back on so that you do not lose any water. And then you can take it out. And as you can see, there is water in the bottom. Now we want to know how much water it obtained, so we put that back into our graduated cylinder. And we measure how much we have. So if I look here, I'm going to again get the level with my container, and we have 50, approximately, I'd say, just over 65 milliliters. So now going back up on the screen where we're recording our data, we have 65 milliliters of water that is sucked up. In addition, if you recall, our cold temperature was about 2.8 degrees Celsius. And this would be degrees Celsius as well. And now what we need to figure out is, we don't really care how much water was sucked up by the bottle so much as we want to know how much empty space there was left in the bottle afterwards. So the way we get this is we just, pretty simple calculation. We take our starting volume of the bottle, which we got from filling it completely to the top with water, and then we're going to subtract how much water was in it after it sucked it up when we cooled it off. So in this case, it would simply be 530 milliliters minus our 65 milliliters, which then gives us, what was that, 465 milliliters. All right, so when doing this lab, you would then repeat this with varying temperatures, trying to keep your hot water as close to the same as you can every time, so that way you can get a variety of data and be able to graph it out. So I've gone ahead and did a graph of the data that I have collected. It should look something like this. So you're going to have your empty bottle volume. You're going to have your warm water temperature, your cold water temperature, volume of water that got sucked up into the bottle, and then your air volume. When you graph it out, you want to kind of graph it out like so, and then insert a trend line. So the trend line is basically a linear function of what you would expect to happen to the volume as temperature went down. So things that are special to note would be where it crosses the x-axis, where temperature reaches 0. It should be somewhere close to absolute 0, which is what, negative 273.15. Ours on this data is a little bit higher, but I'll let you think about some of the reasons why that may be. But anyways, this should give you your relationship. You can see there is actually a linear trend between the volume of gas and temperature. So as something gets hotter, the volume will go up, and as something gets colder, the volume ends up going down.